In day 2 of section 8.2, we're going to tackle some of the trickier problems. To start, let's look at a problem like this one where we have fractions within a larger fraction. I find that it's easier to rewrite these as first fraction divided by the second fraction with that division symbol, because once we see it written like that, it's easier to recognize that we can use the same method for this problem that we've been using all year. Keep it, switch it, flip it. We're going to keep this first fraction, switch this to multiplication, and flip this fraction upside down. Becomes a multiplication problem at this point. We have x's on the top and the bottom. Those will cancel and we're left with 2/3. There's another method that we can use to solve this problem. It's called outies and innies. We take the two things on the outside, the 2 and the x, we're going to multiply them. That goes on the top of the fraction. Innies is the ones on the inside. That goes in the denominator of the fraction. So we'd have 2x over 3x, cancel the x's, and we get that same 2/3. Now that method won't always work. So for example, if we have a problem like this, where we have multiple fractions within a fraction, and they're also separated by pluses or minuses, we're gonna have to use a different method. And for this method, we wanna start by finding the least common multiple. So we look at all these denominators, and we wanna figure out what's the least common multiple or the common denominator for all of those fractions. If we list them out like this, we can just fill in what's missing from each individual number here. So we have a 2, we have a 3, we have a 5. Whatever's missing in that individual number, we're just going to multiply in. So by the end, we have a 2, a 3, and a 5, and all these numbers. This equals 30. Okay, but instead of writing it as 30, let's keep it listed as 2, 3, and 5. So we're going to multiply this least common multiple in to every individual fraction within this problem. Okay, we're going to do it on the top and we're going to do it on the bottom. For example, we're going to take that, we're going to multiply it in with that 6. Now 6 is just 2 times 3, which means this and this is going to cancel, and we're just going to have a 5x left. So it's 5 times the numerator gives us 5x. We redo the same thing with the next problem, or the next fraction within the problem. Okay, so now we take this 2, 3, 5, we multiply it in to that fraction. This time the 3's are going to cancel. 2 and 5 are left, that's 10. 10 times x, 10x. Okay, continue with the bottom here. It's always going to cancel something and eliminate the bottom. Okay, 5 and 5 cancel, 6x is left. And then on the last one, 10 is going to cancel the 2 and the 5. 3 times 7 is left, 21. So that gives us this fraction here, 5x minus 10x over 6x minus 21. We can put together the top here, negative 5x. And remember, we want our answers fully factored. We can take out a 3 on the bottom there. So our final answer for this problem is negative 5x over 3 times 2x minus 7. Same idea for this problem. We have fractions within fractions. They're separated by pluses and minuses, so we can't do keep it, switch it, flip it. We're going to find a least common multiple, and in this problem, it's just an x. If we actually rewrote that 4 and that 3 as fractions, we could see we have x's, we have 1's. It's easy to make everything here into an x on the bottom, but we don't want to do that. We actually want to just multiply in that least common multiple to cancel all these innermost fractions. So times x on the top and the bottom. When we do that, if it has a denominator, it's going to cancel it out like it does here. So just the 2 is left. And if it doesn't have a denominator where it's just 1, that x ends up on the top. So 2 minus 4x on the top. When we multiply into this one, x's will cancel. 2 plus 3x on the bottom. There's nothing we can simplify here, so we're all finished. Sometimes instead of numbers on the bottom, we're going to have some quantities, like in this problem. X plus 5's and x minus 3's. We want a least common multiple, and we're going to get that least common multiple by just giving whichever parenthesis is missing from that problem. X minus 3, x plus 5. At this point, they would both be the same. Our least common multiple is x plus 5, x minus 3. That's going to go to everything in the problem here. When we multiply them, the bottom always cancels out. X plus 5 cancels. 3 times x minus 3 is left. On the bottom, we multiply it in This time x minus 3 cancels. 2 times x plus 5 is left. And then we do the same thing with this other fraction. X plus 5 cancels. This is still here. We get a new one each time, and we have 1 times x minus 3. So it looks like this. We can simplify the bottom by putting these together. This we could distribute, but since we want our answer fully factored, let's just leave it as it is. In the bottom, we can put together these x's, and we can put together these numbers, and we get 3 times x minus 3 over 3x plus 7. Last example, this is the hardest one. The reason this one is the hardest is because our first step in this problem is to factor. When we look at this, we should notice that this is factorable. It's a difference of squares problem, square root both those numbers. We'd end up with 2 parentheses, x plus 2, x minus 2. So once we have that factored, we can find the least common multiple. We have an x minus 2, another x minus 2. I'm only going to write it once. We have an x plus 2, and then we have this x plus 2, x minus 2. Filling in what's missing, and all of these can become x plus 2, x minus 2. That's our least common multiple. Multiply that into everything in our fraction. And when we do, just like on all the other ones, it's going to cancel out specific parts of our least common multiple and eliminate that denominator. So we'd have a 3 times x plus 2 left here. Okay, when we multiply in to this one, everything's going to cancel. Those cancel and those cancel. So just the 6 would be left. So let me show you this completed fraction first. So on the top, we'd have that 3 times x plus 2 minus 6. On the bottom, we're going to have 3 times x minus 2, because that's what's left. And then when we multiply this one in, x minus 2 would cancel. 1 times x plus 2 is left. Okay, we get a fresh x plus 2, x minus 2 with every fraction. Simplify everything we can. So on the top, 6's will cancel out once they're distributed. And on the bottom, we have x's and numbers that we can put together. Here's our solution.